Podcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone, and welcome to today's session, Demystifying Data Science in the Financial Service, with guest speaker Gal Kudu, Director of Credit Decisioning at NewDay. Now, before we begin the session, if you have any questions for Gail, please fire them over via the chat box, and Gail will answer them at the end of his talk. We are recording the sessions, and this will be made available after the session by email. So now I'm going to hand over to Gal to begin the talk.
Good afternoon. Can you hear me and can you see my screen? I'm Gal Kudu and I'm Director of Credit Decisioning at NewDay, as Adam mentioned. I joined NewDay about 5 months ago, and the credit decisioning position or team is something that's been newly created and covers credit analytics, data insights, decision engines, and data science. And today we're going to talk about data science in the financial service. So NewDay is, for the ones that don't know about NewDay, NewDay is one of the leaders in the credit card market in the UK. You might not be familiar with the name NewDay itself, because we trade mainly under some credit card brands like Aqua or Opus, and we also have a portfolio of co-branded cards, partnering with companies like Amazon, TUI, Debenham, House of Fraser, or the Arcadia Group. For us, I would say one of the key things that differentiate us from the rest of the credit card companies is that we really focus on our customers, and they're really at the heart of everything we do. And that's really powered by our manifesto, where we have 4 core principles, being welcoming, understanding, knowing, and rewarding business for our customers. But let's focus on data science in the financial service sector. So data science is at the moment a hot topic everywhere. We can hear about data science, about AI in the press, on television, everywhere. But I would say that the financial service sector is one area where data science can make an impact, and a lot of people are aware of that. And so if you look at just a couple of headlines from Information Age or Lending Times, you can see that they claim, and that's pretty recent, that the future of finance will rely on data science. Lenders bet on artificial intelligence for credit scoring, and then that's something that we do as well as at NewDay. So one of our initiatives this year is, for example, to doubling down on data science. So right now we have 3 data scientists in my team in credit decisioning, and then we're looking at increasing that team to about 10 or 11 data scientists. So that's really hot topic, and we have seen in different sectors that while data science is a hot topic, we have seen some progress on different sectors, like in the medical field, like in e-commerce, but we have not seen that level of adoption in the financial sector. And I believe that there are various myths that prevent the adoption of or a wide adoption of data science in the financial services. Some of them are related to the fact that machine learning is viewed as a black box. So you put data, you get an output, or also related to the fact that even if data scientists are in very high demand, they are likely to be replaced by machines, and then the machines are going to make all of the decisions, and nobody will have any visibility into the decisions made by the machines, and then there will be massive risk associated with that. So in this talk, I'm going to cover 7 different myths that have decided to highlight. That's my personal list. They are way more than that, or you can also consider that some of the ones that I've listed are not that important. And I've also put a few truths after those myths to try to balance the view, and then to not have a too negative view of the environment. But I believe that all of those myths anyways can be busted relatively easily if we focus on them. So the first one is the fact that data science is new to the financial service sector. And I've done a little bit of research on the topic, and actually the first piece of literature mentioning something related to machine learning, something related to an automated way of using data to make decision in credit is dated to 1941 in the US by someone called Dern, and who used discriminant analysis. Then in 1949, Wahlbergs actually found an improvement of 7% versus a holdout sample when using his approach. And then in 1956, the company Fair Isaac was created. They owned FICO score that was actually created way later than that in 1989. And then there are quite a few other papers that talk about incremental progress, usually around 6-7% up to 10%. But those papers are actually still very interesting and still very relevant to our world now. So, for example, Maris and Corners are talking about decrease in losses, but in terms of cost of the number of goods or number of potentially goods that would not be granted credit card or credit. And then a very interesting paper that I found is actually the development of numerical evaluation systems by Myers and Forgy that was published in 1963. And I know my screen is pretty busy, this slide is pretty busy, and then you can barely read, but they mention, so I'm going to read a few extracts of that paper to show you how relevant it is to today's world. So an approach of this sort has been all the more necessary in recent years because of the mushrooming of credit psychology among large segments of the consumer public. That's still very true. The resulting increase in demand as tax credit departments in many larger companies beyond their capabilities to train and maintain an adequate staff or expense credit evaluators, and so on and so on. And it says that in such situations, numerical rating systems have much to offer, provided they can predict credit risk with sufficient accuracy. And that's still something that we face, and that's still something that we have to deal with when we implement machine learning solutions. Another thing that they say later on in the paper, when they list the reason of for lack of adoption of numerical rating systems, the first one is a natural reluctance on the part of the experienced credit executive to abandon the time-honored judgmental approach in favor of newer and relatively untested quantitative rating methods. And even if that's not the intuition of underwriters that you sometimes need to change with machine learning solutions, that's still the intuition of some people that have many years of experience in the sector. And then so you need to find ways of explaining why the model is saying something that might be counterintuitive or black boxy on the surface. Another thing that they mention is the inability of statisticians to develop foolproof rating systems which consistently identify poor credit risk accurately enough to result in substantial net saving by the credit operation. Same thing, we're still facing with not being able to find the perfect model. Then the third point is the difficulties involved in utilizing any such rating system in the operating situation. So it's talking about implementing solutions in a production environment. And then the last one is the unwillingness on the part of statistical consultant to invade the domain of the credit managers. And we are, again, facing similar issues with statisticians or machine learning experts or data scientists not really willing to interact sometimes or to enter the field of financial service or to interact with the business partners within an organization. So nothing is really new here. All of the issues we're wrestling with have been known for over 50 years, 60 years, up to way more years than that. And people have been able to overcome those issues with different approaches over the years, because now we're not facing a change versus individual underwriters, but more versus established modeling or scorecarding approaches such as logistic regression. And at the bottom of my slide, actually, I've also put timelines around some of the machine learning approaches or more traditional approaches to show that none of those approaches are very new either, or are very new to compared to more established methodologies. So the standard approach for scorecarding or modeling in the financial sector for credit is the logistic regression. And one of the founding papers for the use of logistic regression in an applied environment was by David Cox in 1958. And just a few years later, in the early 60s, you have a paper by Marvin Minsky who mentions neural networks. And neural networks are one of the typical black box or so-called black box solutions that are part of the machine learning tool set. If you fast forward to 1995, you have the first paper on random forest by Tinkham Hall, who was working at the time in Bell Labs, that actually was a good source of innovation. And now she works for IBM on Watson, I believe. And then if we keep going over time, in 1999 there was the first paper by Leo Brayman on GBM. Leo Brayman from Berkeley. So those things are like at least 20 years old. Sometimes, oops, I don't know. Sorry. Yeah, so not that recent, and there's nothing new here. The second myth that I already mentioned is related to the fact that machine learning is a black box. And I just took the example of GBM, so the one that was co-invented by Leo Brayman and John Friedman from Stanford. And that I looked at one of the founding papers from Friedman, and that's really interesting to see that in his abstract, he says that gradient boosting of regression trees produces competitive, highly robust, interpretable procedure. So even the founder of the solution or the tool said that it's highly interpretable, and he's not like a magic salesman. He's from Stanford. So I think that there's a lot of myths created around the black box aspect of machine learning that is due to both a lack of understanding from the general public, but also from data scientists themselves that don't dig into the papers or don't try to understand the philosophy behind some of those tools, or actually like to keep that myth alive, because that gives them sometimes a little bit more power. Also, if you look online, and now online is that's a very useful tool, you can find a lot of different attempts at interpreting those solutions, and there's also books around those solutions that actually explain them in detail and explain how to parameterize the different options that you have available. So I don't think that machine learning is really a black box, and it's just for us to make the effort of learning what machine learning is, what the different solutions are, and try to explain them to the various audience we are facing. And GBM is no more complex in terms of the optimization than, or maybe slightly more complex, but not that's not really a blocker when you compare it to logistic regression. And I don't think that a lot of people that use logistic regression and that say that logistic regression is pretty transparent have actually looked at all of the optimization processes and all of the options that you can tweak when you develop a logistic regression. So the third myth, and that one is maybe slightly easier to overcome, that's the fact that the machine is in control and learns by itself. And that's something that actually I've heard very recently at NewDay, and someone was a bit worried about us implementing the first machine learning solution to predict risk at NewDay, because that person was thinking that would be a a solution that would learn by itself and that we would not have any control on which variable would be used, and then the variables would change on daily basis. And then that's definitely not the case for most of, or I don't know if any organization that is trying to implement reinforcement learning, for example, for credit decisioning. And I don't think that's going to happen in the future years. I think that we are far behind automated cars, for example. That can be also pretty scary. And then I think that model development will still be for many years as much an art as a science. Even if if we had like reinforcement learning solutions that would actually help on the data scientist recruitment, because then we would not need any more data scientists, because the computers or the algorithm would do everything. We would not need many people anymore. But that's just a joke. The fourth myth is really that machine learning is open source and it's not reliable. So open source is not reliable. I think that was probably true, or that was a potentially valid myth 15 years ago or 20 years ago, because now a lot of things run on open source. And open source is very reliable, very documented. There's a lot of documentation everywhere, very detailed documentation. The algorithms are used by hundreds or thousands, if not hundreds of thousands of people across the world, data scientists across the world. There's a strong community that would spot a bug very quickly if there was one, and then that keep improving the solutions and the options. So I don't think that that's a concern anymore, and then that's pretty easy to demonstrate. And even if that was the case, very solid algorithm and companies like SAS that actually have been used by modelers and by statisticians and by the first generations of data scientists, have now a lot of machine learning algorithms that run on very stable and proved platform. So then you have the example of tree boost procedure here, that is one of the options on the SAS Miner. So let's move on the fifth myth. Machine learning cannot be implemented. And I agree that that's a massive concern if that's not the case, because in a commercial environment like the one we're in, if you develop solution or potential solutions that you cannot implement, those solutions have very limited value, if any value. And then so for many years, the scorecard approach and then the logistic approach was the only one that people were considering because of the implementation constraints. When you had to recode an algorithm in COBOL or in different languages, or put that in an operational system, that like putting a neural network or putting a GBM was almost impossible given the complexity of it and the number of lines that you would need to translate in plain English and then translate back in simple code. But that's not the case anymore because there have been at least 3 different options that have emerged in the recent years. And then sometimes busting that myth means just refreshing the beliefs of a lot of people in operation or even data scientists. The first option is to use PMML, and then the PMML conversion has improved drastically in the last few years, probably 2-3 years, and then now you can easily convert all kind of machine learning solutions in PMML, and then use PMML in production, or implement PMML code in production. Another one is actually solutions that are like for example Amazon SageMaker, where with just one click you can put in production and then deploy any kind of algorithm that, written in SAS or in Python or C# or whatever you want. And then the third one is that, and that's really specific to the financial sector and then to credit decisioning. The credit decisioning systems or decision engines have caught up with the issue, and now you can you have new entrants like Provneer, for example, or more established solutions like the market leader from Experian, PowerCurve, that offer the possibility of implementing machine learning. And then that's something that we have investigated in the last few months at NewDay, because yeah, we definitely want to implement machine learning solutions and more complex solutions than simple logistic regression, even if that can be based on multiple models, simple models. And so we have investigated some of the solutions, and then we are pursuing right now the PMML route, and we are going to look at implementing a new decision engine for origination in the very near future. We are also in the process of implementing a new decision engine for collection, and then the solutions we'll pick for origination will allow us to implement those machine learning solutions. So I think that's a myth that is pretty easy to bust. The sixth one is actually kind of a funny one in the sense, or the way it's stated, like data scientists are living gods. That's maybe pushing it a little bit, but if you look at the headline of the famous headline of the Wall Street Journal a few years ago, where it says that data scientists are the high priests of algorithms, so there's a link to religion there. There's also the Harvard Business Review article titled "Data Scientist: The Sexiest Job of the 21st Century," and so I think that some data scientists can believe that that's true, and that's something that actually there are different ways of dealing with that myth. But the first one is really to make sure that the data scientists you have in your team or that you're recruiting don't believe that, and are very humble and are able to communicate with their stakeholders and don't really believe that myth, because that's pretty easy to believe that if you see those articles, those headlines, and then you hear that over and over. And I believe that a good data scientist or a good data science team relies on three key elements. You see different versions of what data science is, but a simple one is looking at like three key elements: the domain knowledge, and that's really important in a regulated environment like the financial service, where in order to be a good data scientist or a good data science team, you need to acquire that knowledge. And on that front, data scientists are definitely not the gods, because they have very limited knowledge when they enter that industry, and then that's a very highly regulated industry with very complex strategies, very complex products. So there's a learning curve there. In terms of science, definitely. In terms of engineering, definitely. They can be highly skilled and highly knowledgeable. But in terms of communication, I think that's another element where data scientists need to put an effort on in order to, even if that belief that they are superior, they know a lot, and then they are very intelligent. They need to help their partners in the industry or in any company to approach them and then to work with them on divesting other myths. And then the last point I will make on that myth is that if you think about the objective, and then going back to the first myth, the objective of a model or solution that we develop is not to be the perfect solution, which is maybe what God would want to create, but just to create something that is slightly better than what's in place at the moment. Something that is slightly incremental, 6, 7, 10, 20% better if we are good or lucky. And then that's something that is really human. That's not something that any god would want to tackle. And so that leads us to the seventh myth, which is that data science can solve any problem. That's sometimes when money is invested in a data science team, or in the creation of a data science team, or recruitment of data scientists, that's what people are led to believe. Like a few years ago, they were led to believe that data would solve any problems. Data would be the new oil. Data would be the new bacon, I've heard, and then that data could solve any problem. But then people realized that without people able to interpret those data had no value. And now some people are led to believe that data science or data scientists can solve any problem, and then if you have the data, if you have the data scientist, then all of the problems are easily solved. The first issue that we face is that if your data are not of the best quality, are grossly inaccurate, as mentioned in the cartoon, you're not going to produce anything that is good. So as a lot of people say, garbage in, garbage out. And the second thing is that data science is not magic. as I've mentioned in some of the first myths, everything is relying on strong science. Strong science has been developed by top quality statisticians or machine learning experts, engineers in the past, and then so there's no magic there. Everything can be easily explained, but at the same time, it's not just science, and I think that that's something that maybe is adding to the myth a little bit, or that is keeping that myth alive, is that there's an equal part of art in fine-tuning of those algorithms as we have in science, but definitely not magic. So that's covers the 7 myths, and I think that all myths that I've listed exist. You can encounter them in different shape, and then some of them might be easier to overcome than other. But I think that there are also truths that can help and that are in the process of helping demystify some of those myths. And then the first one is that there is industry-wide progress to demystify machine learning in general, and then move the perception of machine learning away from it being a black box. And some of the leading companies on that front are the companies that provide the bureau data, that provide data, or that provide solutions as well, because that's in their interest to actually help better decisioning and to help improving the solutions that are in place. And I have 2 examples here. One, and they are both coming from the US. One is Equifax, and Equifax recently launched the neurodecision technology, and so that's they claim it's the first neural network that not only improves performance and accuracy, but also provides explanation of what's going on and help on the regulatory front to provide turn-on reasons. In the US, when you extend credit, you have to provide turn-on reason if you don't extend the credit to an applicant. And they have developed a solution that provides that. And that was one barrier to adoption of machine learning in our industry. So I think that's a good step in the right direction. They are one of their key competitors, Experian, is also working on that front. And then I know that, for example, as part of their Power Curve solution, they are providing modules to provide also reasons for any decision that can be made. I know that a lot of players in the industry are also doing the same thing, but less publicly, because it's becoming a strategic asset. So I know that, for example, we are at the last stage of getting our first gradient boosted model approved at NewDay. And then we have worked on solutions such as ice plots, partial dependency plots, Lime shape limiter to help overcome that perception of black box and then that perception of lack of transparency, even if I'll reiterate the fact that the founders like Friedman, for example, clearly stated that GBM is not a black box and is pretty transparent in what it's doing. So I think that we will see more and more in the near future on that front, and then people will become more and more open on sharing the solutions. The second truth is that a variety of modeling approaches can provide incremental performance. And I've just put a few examples of papers that you can find online, and a lot of research is done on what is the so-called best solution, what is logistic better, linear regression, GBM, random forest, neural networks, and then which ones, and then for what type of unbalanced sample or balanced sample, or is it for mortgage, credit card, or other solutions. So there's clear appetite in researching that. There's a lot of work that is done industry-wide, but also in academia on the topic. And again, we're not after finding the perfect solution, but just an incremental solution. And if you read those papers, everyone will have his own opinion on what is the best solution. I don't think that there's one best solution. Sometimes a simpler solution is better. Sometimes one solution, one algorithm is better than another one based on what you're trying to predict, or based on what type of data you're dealing with. But we're definitely exploring different algorithms here. So historically we have been looking at logistic regression, but now we're working on GBM, on other solutions as well, such as neural networks, probably in the future, not at this point, or random forest, definitely. And then the third truth is that even if you don't use machine learning because you cannot implement it, or because there's a lot of resistance, a lot of myth to debust in terms of black box or implementation or interpretability of the solution, there are still a lot of quick wins to have with the machine learning algorithms that are readily available. They can help harvest different data sources. And then we're definitely looking at new data sources that we have readily available in-house at the moment that we didn't tap in the past. We're also looking at external data sources, internal data source that's like harvesting more from the transaction data that we have in-house, or on call center data, on collection data, on contact data points that we get from the customers. And on that front, machine learning or data science is really useful. Interpreting or structuring unstructured data, for example. But also on data sources that have been used for many years. Using data science can allow to get more juice out of those data. For example, on creating new variables, you can actually test way more variables, do transformation, do ETL. More easily with data science and machine learning, and then use some of those variables in a more traditional modeling approach, like logistic regression. There's a lot of feature engineering to find relationship between variables, because with a traditional approach, interactions are not easy to find was the use of more modern machine learning approaches. You can actually create or you can find relationships and unknown relationship and then create new variables. And also on variable selections, because variable selection has been a topic of interest for many years in the industry, and now data science and then machine learning can provide alternative solutions to that. Or when it comes to missing imputation, we have the possibility of testing a lot of different options here. So even if machine learning or data science is not used at the core of the engine, it can still add a lot of value. And there are a lot of quick wins that can be found there. And finally, the fourth truth that I've listed, there's a lot more to data science than just machine learning. So there's that tendency in the financial sector to focus on machine learning when people talk about data science, because the core of the historical decision science or statistics has been on developing models or scorecards to predict risk. But there is way more that can be done. Things that we have done very recently at NewDay are, for example, using fuzzy matching to create a single customer view of a customer, because historically when it was hard to figure out which customers had multiple accounts or not. We have also built a segmentation of our customer base using a Gaussian mixture modeling approach, which is much better than traditional K-means approach that is the typical approach taken for segmentation. There's also possibilities of interpreting what the customer say or express through sentiment analysis, and there are just few examples of what data science can be. So that's again a lot of truths and myths to debust, but I don't think that's the. So it started a long time ago, probably 100 years ago, and it didn't start with data science. Data science is now here to help improving the relationship with the customer, improving what we can do with data to provide better solutions to our customers, but it's not the end of the road, and so the journey will not end with data science. I don't know exactly where it will end, if it will end at any point, but I know that data science can definitely contribute and then will contribute to the path. And that's like incremental contribution, one step at a time, and then that's been the case for the last probably 80 years already. On that note, I will mention one thing, is that we're looking for people to help us progress on our path at NewDay. That's the mandatory recruiting slide. So I've put the link on LinkedIn and links for 2 roles that we are recruiting at the moment. As I mentioned earlier, we are looking to really double down on data science to significantly increase our team in credit decisioning. And you will be very welcome to reach out to me or to our team to discuss what we are trying to do in more details. I will open it to questions. If you have questions, we have about 10 minutes for question if the audience has any question. Have one question. First question, what is the most important myth to bust? Again, those 7 myths are just personal view on the myth to bust. But if I had to pick one that is maybe the most important myth to bust, I would say myth number 5, on the implementation, because I believe that if you cannot implement a solution, that solution will not have any value. And then so a lot of people that believe that you cannot implement machine learning will not even want to invest in data science, to even look at it, and data scientists themselves might be demoralized if they believe that the best solution they are trying to create cannot be implemented. And then that's a relatively easy one to debust at the moment, because as I said, there are now solutions, and then the solutions are improving on a very regular basis and very exponentially at the moment compared to a few years ago. Any other question?
Hi, Gal. We've had some questions come in through via the chat box. If you can take a look, if you can see them there.
Yes. Yeah. What are the methods you use most on a day-to-day basis with your team? I don't know if that's a technical question in terms of which methods, like which algorithm we're using, or if it's more like way of working question. In terms of way of working, we are trying to adopt an agile approach, because again, we're looking for incremental improvements, and we at the moment we're really in a phase where we are demonstrating the value, or starting to demonstrate the value in a concrete way to the business and to our key stakeholders, and then so that's why it's important, I believe, to take a very incremental approach and have like short cycles of a few weeks to demonstrate the value and to implement that value to start harvesting it, and then to go after the quick wins. There's another. What is the status of regular reporting at NewDay? That's something that we are in the process of improving as well. So right now, most of our reporting is traditional reporting. So very on monthly basis or daily basis or weekly basis, but very reactive in the way we interpret our reports, and we are looking at actually improving that, and then moving towards a more proactive approach to generating insights from our reports. And also that's an interesting point, also looking at introducing machine learning into our report to actually find ways of improving the return on investment from time investment, mainly from those reports, and then to generate insights quickly. But yeah, we are in the process. So a lot of our reports were done with SAS and Excel, and we're moving towards Tableau. But Tableau is really a very intermediary step, something that is useful for the business analytics side, but we are in the process of adding machine learning to it. What tools do you use internally to help you with data science? So until recently, we were SAS-only shop. So all of the models, all of the analysis were done with SAS and SQL. Now we have moved to Python, and we are in the process of using other tools as well, but we have decided to adopt Python as the first open source tool before moving to before adding to more solutions to our toolkit, and we're looking at using other things like Spark and SageMaker in the near future. I think that's all of the questions. So I will thank you all for listening, and feel free to reach out to us if you have more questions, or if you're interested in discussing other myths that you believe are pretty important, or other truths that you have found. I'm really open to discuss those things, and then to learn from other people in the industry or outside of the industry as well. On that note, I will close this webinar.